Somewhere far beyond the reach of light, beyond the pull of galaxies and the hum of radiation, there may exist something stranger than anything we've ever seen. Not a black hole, but its reflection. Not a mouth that swallows everything, but a wound that pours outward, endlessly, violently, refusing to let anything in. It is the inverse of collapse, a reversal of silence, a white hole. We've never observed one. Not in sky surveys, not in radio telescopes, not in the soft patterns of background noise, but in the same equations that whispered of black holes long before we believed them real. Something else quietly appeared. Possibility, asymmetry. If black holes end stories, then white holes begin them, not gently, but with force, with eruption, as if the universe itself were throwing something back. And if that's true, then maybe these aren't just mathematical ghosts. Maybe they exist where time folds, where gravity forgets, where the universe bends too far and has no choice but to snap. Maybe what we call the Big Bang wasn't a beginning at all, but a reaction, the other side of something else collapsing, the echo of a death we were never meant to witness. We often imagine the black hole as the ultimate destination, a one-way passage through the floorboards of space, where matter falls and vanishes, never to be seen again. In the mind's eye, it is a thing of violence and finality, an object that holds no light, no memory, no escape. But behind the curtain of observation, beneath the surfaces we can measure, the mathematics tells another story. Because within the same field equations that gave birth to the black hole, those strange, curving descriptions of gravity and spacetime that Einstein left us, there is something hidden, something inverted, something that does the opposite. The equations don't favor darkness. They are indifferent to metaphor, but when solved fully without simplification, they offer not just the shape of collapse, but the shape of rejection. Not a place where everything falls in, but a place where nothing can. A region of space that doesn't devour, but expels. Not a gravitational sink, but a fountain. Not death, but resistance. The equations do not call it this, but we do. We call it a white hole. It emerges not as a discovery, but as a consequence, a symmetry solution. If you take the math that describes a black hole and reverse time, run the film backward, the structure still holds. Gravity still curves. The shape of spacetime remains valid. But the direction shifts. Instead of collapse, there is explosion. Instead of everything falling toward the center, everything rushes away. The singularity still exists, but now it pushes rather than pulls. The surface, once called the event horizon, becomes a barrier in reverse. Nothing can enter, but everything inside must come out. This is not science fiction. It is the result of treating the laws of physics as time-symmetric. That is, rules that don't care whether time moves forward or backward. Newton's laws worked this way. So does Einstein's general relativity. And so, in this view, the black hole is not a singular phenomenon. It is one half of a larger symmetry, mirrored not in the observable universe, but in the abstract terrain of math. And yet, despite the elegance of the idea, something about it feels off. The black hole was once thought unphysical too, just a curiosity of theory, but we have since measured its shadows, listened to its collisions, mapped its influence on the dance of stars. The white hole, by contrast, remains only in the math. It is pristine, beautiful, unbroken, and, perhaps for that very reason, unreal. Because the universe, for all its grandeur, does not often favor ideal forms. Nature is messy, asymmetrical. Time moves one way. Heat flows outward. Entropy increases. We see things fall, but never unfall. We see stars collapse, but never reassemble. So how can an object exist that does not absorb, but only emits? That does not grow, but shrinks? That does not forget, but insists? If the black hole is born from the death of a star, what gives birth to a white hole? This is the mystery, because while the white hole fits neatly into the same theoretical framework as its darker sibling, it has no story, no mechanism, no formation. We can describe what it does, but not how it comes to be. It is an answer without a question, a sentence without a beginning, And yet, the equations insist. They say that if black holes exist, and they do, then white holes are not just allowed. They are demanded. Their absence, in a way, is what breaks the symmetry. And so physicists are left with a strange tension. Accept the white hole as a pure mathematical ghost, or try to imagine a universe strange enough to birth one. Some have tried. They say, what if white holes are born at the beginning of time? Not formed from stars, but existing before stars existed. What if the Big Bang itself was not the creation of matter from nothing, but the ejection of matter from something? A white hole vast beyond imagining, exploding not in space, but into it. A beginning that is really an end, inverted and obscured by time. Others wonder whether white holes might be born from black holes themselves. That perhaps the end state of a collapsing star is not an eternal pit, but a transformation. That something happens at the singularity, a reversal, a bounce, a release. That the same object, observed in another frame, another time, another part of the cosmos, might appear not as a devourer but as a fountainhead. The whole doesn't just end. It erupts. But these are speculations. Hush theories on the edge of what can be tested. Because if a white hole were to exist, how would we find it? It would not pull in matter. It would resist. It would shine briefly, then vanish, leaving behind only particles scattered through cold space. No gravity well, no accretion disk, just a signature without a source. Still, the idea lingers, not because we've seen it, but because it refuses to go away. Because in the long quiet of physics, the math whispers of balance, of opposites, of forms that fold back on themselves. And perhaps, if the universe does favor symmetry, then the black hole cannot stand alone. Perhaps its mirror waits, not in the stars we see, but in the ones that have not yet formed. Not in this time, but in another. A place where everything that was once taken will someday be returned. Or maybe it's already happening. Maybe what we call the past is simply what the white hole has given us. And the future is where the black hole will take it away. And we are what exists in between. We often imagine that discovery begins with a telescope, or a spark in a particle accelerator, or a silent photograph from deep space. But some of the strangest things in the universe weren't discovered in the sky. They were discovered in silence, in math, in the careful unraveling of equations written on a chalkboard by someone staring at symbols that should have been meaningless, but weren't. It was there in 1916 that Karl Schwarzschild, while serving on the front lines of a war he wouldn't survive, solved the equations Einstein had just released. He wasn't looking for a black hole. The term hadn't been invented. No one even believed such a thing could exist. But the solution he found wasn't empty. It bent space in on itself. It hinted, in its curvature, at something invisible, something irreversible. A singularity, a place where space-time falls inward forever. That solution would become the foundation of what we now call the black hole. But Schwarzschild's math contained more than just a sinkhole. It hinted at structure beyond what anyone could see. If extended, the solution allowed for something else, something strange. Something that wasn't a black hole at all, but its time-reversed twin. If gravity could bend inward, it could, in theory, bend outward. If space could collapse, it could also explode. And if a black hole was a one-way street into silence, this other object was a scream in reverse, a place that only emitted, never absorbed. This strange mirror came to be known years later as the white hole. But it was never born from observation. Came from a question, what happens if we take the black hole and turn time around? In physics, most of the laws don't actually care about direction. If you flip time in Newton's equations, the math still works. A ball that falls down can just as easily rise back up. A planet can orbit forward or backward. Even the rules of general relativity, Einstein's grand description of gravity, are indifferent to the arrow of time. They bend the same way whether you're moving ahead or behind. That's the heart of symmetry. That's what makes white holes mathematically inevitable. But math is one thing. Reality is another. Because when you imagine reversing time, it isn't just the object that changes. It's everything. A white hole doesn't just spit out light. It undoes causality. It violates intuition. Imagine an explosion you can never get close to. Not because it's dangerous, but because it's impossible. You approach it and you're repelled. You try to throw something in, and it comes flying back out. The entire structure seems to reject the very idea of interaction. It exists, but only as a kind of refusal. In that sense, the white hole is not a place, it's a boundary, a firewall. Not something you fall into, but something that forever lies beyond reach. And yet, the equations insist. If we take time seriously, if we treat physics with the symmetry it demands, the white hole cannot be erased. Still, for decades it was. Most physicists ignored the white hole solution. They called it unphysical, unstable, a relic of oversimplified models. Because to admit it was to admit something stranger. That time itself might not be as solid as we think. That the arrow we feel, from past to future, from cause to effect, is not built into the laws, but into our perception. And that somewhere out there, or deep in the fabric of what holds reality together, the reversal might already be happening. Some resisted this idea with silence. Others tried to bury it beneath more practical pursuits. Black holes, at least, had observational consequences. They warped orbits. They consumed stars. They left shadows that telescopes could photograph. But white holes, what would they leave behind? Nothing that stays. Only what escapes. Only the aftermath. The residue of an event you can never reach. And yet, despite the skepticism, the idea remained. Not in textbooks, perhaps. Not in lecture halls. But in the margins of notebooks. And in the back corners of minds that couldn't let go of symmetry. The white hole wasn't accepted, but it wasn't forgotten. It became a shadow in the math. A presence without a proof. A possibility that whispered from the folds of the very equations that shaped our universe. And so we are left with a question that is deeper than physics. Not whether white holes exist, but what it means for something to exist in the first place. Is an object real because we can see it, or because the math says it must be there? What happens when the universe tells you, in numbers and curves, that something ought to be, but offers no light, no sound, no sign? Do we discard it? Or do we wait? Maybe the white hole is not something we will find, but something we will become capable of noticing. Maybe it is not a place, but a consequence. A reversal not just in space, but in thought. A kind of symmetry we have yet to learn how to feel. Or maybe it has already happened. Maybe what we call the beginning was really the middle. Maybe the universe has already passed through the white. Maybe that's what gave us time at all. And maybe the only reason we don't see it is because we're still moving forward. If time can run both ways in the equations, then the black hole is only half of the answer. The other half, the white hole, sits on the other side of a mirror we're not supposed to look into. But the symmetry is seductive. If something falls, something must rise. If there is collapse, there must be expansion. And yet, when we speak of time running backward, we are no longer just speaking of physics, we're speaking of perception, memory, direction, and consequence. The universe, as we experience it, is full of asymmetries. We crack an egg, but it never uncracks. We grow old, but never young. Ice melts, never unmelts. And this directionality, this forward motion, is not written into the equations, but into the world we occupy. Into entropy, into our biology, into the strange way consciousness seems to ride on the arrow of time like a leaf caught in a current. So when a solution like the white hole appears, symmetrical in form but opposite in direction, we don't just question its physics, we question its meaning. What does it mean for something to emit time in reverse? To explode outward from a singularity that we cannot approach? To push matter out into space that hasn't yet arrived? This is where mathematics begins to collide with something more elusive, our assumption that things must make sense from the inside. That reality is structured in a way we can follow step by step, from past to future. But white holes, if they exist, do not cooperate. They are events we cannot approach, but which still affect us. They are echoes from nowhere. They are consequences without cause. And perhaps that is why physicists spent so long turning away. Not because the math was wrong, but because it refused to explain itself. Still, buried in the deeper geometry of spacetime, the white hole lingers. In the extended Kruskal-Zachary's diagram, the full analytic continuation of the Schwarzschild solution, the white hole is not a trick or a curiosity. It is a region of spacetime that mirrors the black hole across a kind of temporal boundary. And in that diagram, the singularity isn't just a point, it's a bridge. Something that connects inflow to outflow, collapse to eruption, death to birth. A cosmic inhale followed inevitably by an exhale. But these diagrams are not photographs. They are maps of logic, not of matter. They are blueprints of how spacetime could be, if only the conditions were allowed. If the universe were perfectly symmetrical. If nothing broke. If entropy ran backward. And in a universe like that, perhaps white holes would be common. Expected. Natural. But that is not the universe we live in. Ours is fractured. Asymmetrical. Chaotic. And still, the whisper of the white hole remains. Because some believe it might not be a contradiction after all. That maybe our mistake was in thinking the white hole had to exist now. That maybe it existed before, at the very beginning. That the Big Bang itself, the great outpouring of all matter, energy, and space, was not a singular moment of spontaneous creation, but the visible surface of something else. Something reversed. Something collapsing from somewhere else. In this view, the white hole is not a separate object, floating somewhere in the stars. It is everything. It is where we came from. It is the throat through which all of existence was poured. Not a star, not a particle, but a boundary between eras, the rebound of a cosmic fall, a bounce, not from nothing but from everything that came before. This is more than poetic speculation. In the equations of loop quantum gravity, a theory that tries to unify general relativity with quantum mechanics, there are hints of such a bounce. A suggestion that singularities do not remain singular forever. That spacetime, when compressed to the smallest scales, fights back. That instead of ending, it rebounds. Instead of crumpling into oblivion, it explodes into a new phase. And what we see as a beginning might simply be the continuation of something else's end. But this is where the mystery deepens. Because if the white hole is the other side of the black hole, and if time is the axis that connects them, then we are forced to ask what lies between. What flows through the middle? What travels across? And more importantly, can anything survive the journey? These questions remain unanswered. The math suggests possibilities, but nature has not confirmed them. We have not seen a white hole. We have not measured its heat, its light, its resistance. We have only imagined it, modeled it, followed the logic until it led us into the dark. And maybe that's the point. Maybe the white hole isn't waiting to be found, like some star hiding behind a dust cloud. Maybe it exists as an implication, as a pressure, as a reminder that even in physics, the mirror must be acknowledged. That for every side we see, there may be another we never can. And so we stand, caught between what the math demands and what the universe reveals. A species built on symmetry, living in a cosmos that rarely gives it. And somewhere, perhaps in the silence between equations, the white hole continues to shine, not in light, not in energy, but in the possibility that endings are never complete and beginnings are never quite what they seem. It's easy to think of physics as a set of rules etched into the fabric of the universe, firm and unchanging. But sometimes those rules give rise to things that feel more like riddles than realities. The white hole is one of them. It was not discovered. It was implied. It emerged not from starlight, but from symmetry. It belongs to a category of ideas that math cannot let go of, even when nature remains silent. We don't know why the universe permits black holes. We only know that it does. Stars burn out, collapse, and vanish into points that devour everything around them. We've seen it happen. We've measured the gravity, traced the spin, even heard the echoes of their collisions. But white holes are different. They don't emerge from dead stars. They don't seem to form in any way we can imagine. Instead, they burst forth, complete and isolated, without warning, without cause. They are not part of the life cycle of a star, but perhaps part of something older, something deeper. Some have tried to explain them as temporary phenomena, not real objects, but brief events. Explosions that happen so fast, so violently, that they barely exist before they're gone, like a flashbulb in reverse. They suggest that a white hole might appear as a sudden burst of matter and radiation, flaring out into the vacuum of space, then disappearing without a trace. But if that's true, how could we ever hope to find one? They would be over before we could even look. Others propose more radical ideas, that a white hole isn't an isolated event at all, but the visible tip of something else, something larger. That what we call a white hole might be the mouth of a tunnel, a doorway, a bridge, that it connects to a black hole somewhere else, someone else, and that the two form a single structure twisted through space and time. In this vision, a white hole isn't just an emitter, it's an exit. Not an origin, but a destination. The place where the contents of a black hole finally reappear. But even this is speculation built on speculation. These tunnels, called wormholes, are fragile, unstable, and possibly imaginary. They tear under their own gravity. They collapse the moment you try to pass through. And yet, the white hole keeps showing up in the math, patiently, persistently, as if reminding us that not everything impossible is false. This is where physics begins to resemble myth. Not in its truth, but in its language. The white hole is a concept we can barely picture, a phenomenon we cannot reach, born from equations we still do not fully understand. It is not a thing. It is the idea of a thing, a placeholder for balance, a whisper that every great consumption must be matched, eventually, by release. And maybe, in a universe governed by symmetry, this is not just desirable. It is necessary. But symmetry is not always visible, can be broken, hidden, buried beneath layers of complexity we have yet to peel away. And so, even if the white hole is real, even if it plays some secret role in the cosmic script, it may remain forever out of reach. A mathematical ghost, a rumor passed down through generations of equations. Something we believe because the logic demands it, and because reality hasn't yet said no. Still, something strange happens when we let our minds follow the path the white hole lays out. It changes the way we think about time, about endings, about origins. If black holes consume everything, then white holes suggest that nothing is ever truly lost, that what disappears must reemerge, that death is not a deletion, but a delay. Maybe this is the deeper purpose of the white hole, not as a physical object, but as a conceptual balance. A way of reminding us that the universe does not just collapse inward. It also pushes outward. It does not only fall. It rises. Not always. Not everywhere. But enough. And so we continue to write the equations. We test them, stretch them, bend them until they break. We wait for the universe to respond. And in that waiting, we become something strange ourselves. A species that listens not only to what is seen, but to what must be true, even when it hides. Perhaps the white hole will never be found. Perhaps it is not the kind of thing that exists in space, but only in the spaces between ideas. But even then, it matters, because it reminds us that every time we thought we had reached the edge, we hadn't. There was always another side, another face, another mirror, and maybe, somewhere far beyond what we know, the universe is already telling this story in reverse. Collapse happening backward. A silence erupting into sound. A white hole, not in theory but in truth. And maybe, we've been part of that story all along. For all its silence, the universe is rarely still. Behind the cold light of stars and the quiet drift of galaxies, there are signs, whispers, echoes, ripples left behind by events we cannot see but somehow feel. And when physicists speak of white holes, they do not speak only of math. They speak of strange clues, faint disturbances, patterns so delicate they might just be accidents, or the fingerprints of something we don't yet understand. One of the most persistent mysteries in modern cosmology is the expansion of the universe. Not just that it's expanding, but how. When Edwin Hubble first measured the redshift of distant galaxies, It revealed that space itself was stretching, everything everywhere moving apart. But the shock came later, when we realized that this expansion wasn't slowing down, it was accelerating. As if the universe were being pushed from within. As if somehow something was driving it apart. That something was named dark energy. Not because we understand it, but because we don't. It's invisible, untouchable, and seems to make up nearly 70% of the cosmos. And yet, its effects are precise. Almost too precise. The energy density of the vacuum, this strange force that fuels expansion, has a value that appears finely tuned. Not so large that it tears galaxies apart, but not so small that the universe collapses back on itself. Just enough. Just barely enough. Balanced on the edge of permanence. To some, this is a coincidence. To others, it feels like a clue. Because if there were ever a signature of white holes, not as objects but as events, this could be it. A gentle pressure from nowhere. A hidden residue of something erupting far beyond our view. What if dark energy is not a substance, but a consequence? What if the expansion we see is not just the echo of the Big Bang, but the continuation of an older outpouring? A silent push from something we've never observed because it doesn't pull, but only releases. This is not the only place the evidence whispers. In the oldest light of the universe, there are marks. The cosmic microwave background, the faint afterglow of the Big Bang, is not uniform. It is speckled, textured, imperfect. It carries within it the shape of early sound, the scars of inflation, the noise of creation, and somewhere in that noise, some claim, are patterns that don't quite fit. They call them cold spots, circular anomalies, places where the temperature is lower than it should be, arranged in ways that seem almost deliberate. Like rings, like ripples, like echoes. Theories have emerged suggesting that these patterns could be remnants, not of this universe, but of others. Cycles before our own. Worlds that lived and collapsed and left behind only their shadows. Or perhaps white holes not as objects drifting in space, but as events stamped into time. It is tempting, dangerously so, to see intention in these imperfections. Our brains are built for patterns. Our species survived by finding shapes in chaos. But this is not superstition, it is a question. What are we looking at? Just noise? Or memory? Is the universe smooth because it was born that way, or because something smoothed it? And in the quiet center of this search, there is a paradox. A theorem written in the language of logic, called the Borde-Gus-Vilenkin singularity theorem. It states simply that any universe which expands, on average, must have a beginning. That you cannot stretch space forever in reverse. That at some point it must converge. But this beginning is not necessarily a boundary. Could be a bounce, a shift, a change of direction, which brings us back to the white hole. Because in some models, particularly those drawn from loop quantum cosmology, what we call the beginning is not a creation at all. It is the rebound of a contraction, the moment when space, compressed beyond limits, pushes back. In these models, the singularity never forms. Time never stops. Instead, it flips. The black hole becomes a white hole. The arrow reverses. The collapse turns into release. And what we see as a birth is actually a memory of death. But if that's true, why don't we see it? Why haven't we found white holes scattered across the sky like monuments to old explosions? Maybe because they don't last. Maybe because they're too fast. Maybe because they happened long before we had eyes to look. Or maybe we're already inside one. Maybe what we call the universe is not the place where the white hole happened, but the white hole itself. Process still unfolding. A boundary still erupting. Push still pushing. And if so, then we are not just observers. We are passengers. We are part of the exhalation. Matter thrown outward. Light in the stream. Consciousness riding the wake of something ancient and invisible. Not witnessing a white hole, but being it. There's a strange discomfort in the idea that the universe might be speaking to us not in words or signals, but in patterns buried so deep they vanish into the noise. A cold spot, a missing particle, a barely measurable ripple in the background of time. And yet, over and over again, these echoes persist. each too small to claim certainty, but too persistent to forget. And perhaps nowhere is that tension more alive than in the cosmic microwave background. We often call it the afterglow of creation, but in truth, it's the oldest light we can still see. Not the light of stars, but of space itself, when the universe was only 380,000 years old and everything was fire. That light has stretched for nearly 14 billion years, redshifted into microwave frequencies, bathing the universe in a cold, uniform hum. But uniformity is never complete. There are tiny fluctuations, trillions of a degree in difference, mapped in exquisite detail by satellites like WMAP and Planck. And in those fluctuations, some physicists see something strange. They see scars, not random, not statistical, but deliberate. One theory suggests they are the bruises left behind from previous universes, regions where our cosmos collided with others before this version of time began. Another theory proposes that they're the birthmarks of white holes, explosions that didn't happen during the Big Bang, but after, scattered through spacetime like ruptures in the fabric of expansion. In both cases, these marks defy what the standard model predicts. They don't belong, and yet they are there. Skeptics will say this is confirmation bias, that we're seeing ghosts because we want to, that cold spots and anomalies can occur by chance, and that assigning meaning to them is like reading prophecy in tea leaves. And maybe they're right, but science has always lived on the edge between skepticism and vision. The cosmos has never been in the business of making itself easy to understand. Sometimes it speaks only to those who are willing to sit in silence and listen for years to a signal that may never come. And still, the strange hints continue. Gamma ray bursts, brief, intense flashes of radiation from distant corners of space, arrive suddenly, without warning, and disappear just as fast. We've cataloged thousands, and we think most come from massive stars dying in distant galaxies. But not all. A handful seem to appear without origin, without host galaxies, without anything that should cause them. Could these be white holes? Brief eruptions of matter and energy that flash into existence, expel their contents, and vanish? No one can say for sure, but the theory at least allows it. White holes, by definition, cannot be approached. They cannot be fed or disrupted or measured from within. They only give. They only release. And if such an event occurred in the distant past or even nearby, it might look very much like the mysterious gamma flashes we've seen. A burst of light, a flow of matter, then silence. But even stranger are the questions that arise when we stop looking for the white hole in space and start looking for it in time. Because if time is not a line, but a loop, if the fabric of the cosmos folds back on itself, then maybe the white hole doesn't happen alongside us. Maybe it happens before us, or after. Maybe it's not something we observe, but something we pass through. Something that comes before memory, before entropy, before even the rules we call physics begin to take shape. In that view, the universe is not expanding into nothing. It is still emerging from something. And that something, silent and unreachable, may be what we call the white hole. This is where the lines blur between theory and theology, between physics and philosophy, because to imagine a white hole as the origin of all things is to reshape the story we've told ourselves for centuries. It's no longer a universe born from nothing, but from elsewhere, not from emptiness, but from reversal. The universe as a bloom, not out of void, but out of memory. A push so ancient, so deep, that even time forgot it was there. And if that's true, then the universe doesn't just contain white holes. It is one, a single, vast eruption still in motion, still unfolding. The stars and galaxies, the hydrogen and carbon, the thoughts in your head, they are all the byproduct of a release we can't explain. And somewhere beyond the edge of detection, the origin still pulses, not in space but in the logic of space, keeping time with laws we haven't yet learned to hear. But maybe we're starting to. We often imagine that science is the art of answers. But sometimes, it's the art of persistence, of waiting in the dark, watching for a pattern that may never appear, or listening for a sound that might be your own breath echoing back. And so the search for white holes continues, not with certainty, but with suspicion. Because the universe has a way of hinting, of tugging at the corners of what we think we understand. There are scientists today who don't dismiss white holes as impossible. They treat them instead like rare, decaying phenomena, brief, unstable objects that form under extreme conditions. Some have speculated that white holes could emerge from the death of a black hole. Not in the way you might expect, not as some balanced explosion in space, but through a strange process where the black hole ages, loses energy through Hawking radiation, shrinks, and then, when its mass becomes small enough, undergoes a final phase. One last pulse. A release. A transformation. In this picture, the black hole doesn't vanish quietly. It shifts. The final moment of decay is not silence, but reversal. Not annihilation, but change. And in that change, it becomes something else. Something that expels the matter it once trapped. A white hole, not born from stars, but from time. The idea is speculative. It lacks observation, but it offers something we haven't had before. A mechanism. A path from collapse to release. A bridge across the singularity. Loop quantum gravity suggests something similar. That spacetime isn't infinitely divisible, but comes in discrete chunks. That at small enough scales, the rules of general relativity no longer apply, and instead of infinite density, we find resistance. A kind of quantum pressure that stops the collapse, bounces it, turns it around, not with force, but with inevitability. And the black hole, having reached the bottom of reality's well, is flung upward again, not in space but in time. This opens up a strange possibility, that every black hole is a doorway, that somewhere, in some future, it erupts not here but elsewhere, that what is consumed is not lost, but delayed. And when it re-emerges, it does so not quietly, but in flash and fury, as a white hole, as an exhalation written across another corner of spacetime, maybe even as a new universe. Some cosmologists have taken this idea seriously. They've built models where our own universe is the interior of a black hole that formed in some larger cosmos. That when a star collapsed in that parent universe, it didn't just die, it expanded inward. And what we call everything is the result. A white hole's explosion, seen from the inside. An entire cosmos unfolding within a pocket of reversal. If true, it would mean that universes breed like seeds, that every black hole gives birth, that every collapse is a beginning, not just for energy or matter, but for time itself. This sounds like fantasy, but the math doesn't flinch, permits it, it even encourages it. And if there's one thing we've learned from the history of physics, it's that math often knows before we do. Still, the white hole remains in the shadows, not because it isn't real, but because we haven't yet learned how to see it. It may not be visible through telescopes. It may not linger long enough to catch. It may require us to stop thinking in lines and start thinking in loops. To imagine time not as a one-way arrow, but as a conversation, with past and future always whispering across the present. Because perhaps the white hole isn't just out there. Perhaps it's also behind us, beneath us, before us. Perhaps we've already passed through it, carried by its violence into the silence that followed. Perhaps the Big Bang wasn't the start, but the shockwave. The white hole not as a destination, but as a launch. The spark that flung dust into stars, stars into life, life into thought. And now here we are thinking about it, listening to the noise, watching the numbers, wondering if the faintest cold spot, the quietest burst, the slowest expansion, might be more than just chance, might be the breath of something immense and invisible, something ancient, something that once erupted and left the rest for us to find. Maybe we will find it, maybe not. Maybe the white hole is not waiting to be discovered, but to be remembered, because in the end, it may not be a thing at all. It may be the act of becoming. The moment when everything changes direction, when falling becomes rising, when silence becomes voice. And maybe that's what the universe is doing now. Speaking, slowly, through background radiation, through impossible coincidences, through equations that refuse to lie still. Maybe it's trying to remind us of something we've always suspected but never understood. That what begins must have come from something else. And that even in the deepest collapse, there may still be room for escape. We imagine black holes as endings. Final, unforgiving, absolute. A one-way journey into silence. A boundary that no light, no matter, no thought can ever cross again. But what if that isn't true? What if the black hole is not the full story, but just the first half of something stranger? In the quiet equations of loop quantum gravity, a different possibility emerges. One not made of speculation, but of structure. This theory suggests that spacetime is not infinitely divisible. That, at its smallest scale, there is a grain, a texture, a limit beyond which nothing can compress further. And when a black hole shrinks to that scale, when it loses enough mass through Hawking radiation to approach this quantum threshold, something happens. Something unexpected. It bounces, not with a sound or a spark, but with a reversal. The inward fall becomes outward motion. The collapse becomes expansion. The black hole, in its final breath, gives rise to something new. A white hole. Not a twin, not a sibling, but a transformation. The two are not separate objects, but two faces of the same geometry, separated by time. It is as if the singularity, so feared and mysterious, does not mark an end, but a turning point. And instead of remaining trapped, everything that once fell in begins to fall out. Not back into the same world, but perhaps into another. Or perhaps into the same world, but so far displaced in time that cause and effect lose their grip. Because in this vision, time is no longer a line. It is a funnel, one that narrows and then widens again. On one end, the black hole swallowing stars, compressing matter, erasing history. On the other end, the white hole emitting energy, revealing nothing of its past, starting fresh. But here's the twist. The ends of this funnel are not necessarily connected in the way we expect. The black hole may die billions of years after it was born, but the white hole it becomes might appear before, or after, or nowhere we can predict. It's not that time runs backward. It's that time loses its anchor. To us, this sounds impossible. Contradiction. But in physics, paradox is often just unfamiliar perspective. In general relativity, time is not absolute. It bends, stretches, slows, and loops. It depends on motion, on gravity, on context. So when we talk about a black hole transitioning into a white hole, we're not just talking about matter shifting, we're talking about time itself changing shape. Imagine a star collapsing. Over millions of years, it contracts, its core hardens, gravity overwhelms all resistance. Eventually, it forms a black hole. The event horizon locks in place. Light cannot escape, but deep within, the process continues. The black hole emits Hawking radiation, slowly, imperceptibly. Over trillions of years, it loses energy. It shrinks, it dims, until, in its final moment, quantum gravity takes over. The collapse halts. The geometry rebounds. But now imagine that this rebound, the formation of the white hole, does not happen at the end of the black hole's life in the usual sense. It happens in a different temporal frame. One that's disconnected from the timeline we know. The black hole ages billions of years from our perspective, but the white hole it gives rise to appears elsewhere in time, perhaps even at what we would call the beginning of the universe. This leads to a strange conclusion, that white holes might not be separate entities born independently but echoes, reverberations of ancient deaths playing out across time. That what we see as an eruption of matter, bright and sudden, might actually be the final act of a collapse that happened so long ago, its origin is beyond our horizon. It also means that cause and effect, so sacred in everyday life, might not hold at the cosmic scale. That the cause of a white hole could lie in our past, or our future, or in neither. And if that's true, then we might be living in a universe where the boundaries between beginning and end are not just fuzzy, but fictional. Where everything we call final is just the start of something else, seen from the wrong angle. The black to white hole transition is more than a clever idea. It is a new way of thinking about life, death, and time. It forces us to reconsider what it means for something to be over, to ask whether destruction is ever truly complete, or if the universe has built into it a kind of natural resurrection. And if every black hole is destined to become a white hole, then the cosmos is littered not with tombstones, but with seeds. It's strange to imagine that something as dense, as final, as terrifying as a black hole might carry within it the blueprint for its own undoing. That behind the veil of total collapse, something quieter waits, not to destroy but to release. And yet that's what the mathematics implies. That gravity, for all its power, is not a trap with no escape. It's a motion with a hidden mirror. In this mirrored picture, the black hole doesn't simply vanish into nothing. It tightens, grows old, and then reaches a kind of turning point. A place where space and time themselves refuse to go further. And from that refusal, a reversal begins. Not as a bang, not as a flash, but as a slow uncoiling, a pressure too deep to notice until it breaks into the visible world. And if time itself curves in such a way, the strange result is this, that the end of the black hole may not line up with the beginning of the white hole. Not just in space, but in time. The moment of collapse and the moment of release are connected but not synchronized. A star dies, a black hole forms. It shrinks, it radiates, it contracts for eons. And then, without warning, its contents reemerge. Not next to it, not when it ends, but far away. Perhaps long after, or even long before. The equations don't care about our clocks. Some physicists propose this as a kind of two-way funnel. On one side, gravitational collapse. On the other, explosive release. But what flows through it is not just matter or energy. It's time itself, twisted into something we don't recognize. The black hole appears to end. The white hole appears to begin. But neither is truly isolated. They are connected, like opposite poles of the same pulse. And that pulse can stretch across billions of years. So the white hole we might observe today, if we ever did, could be the echo of a collapse that happened before our solar system was born. Could be a message written in matter and light, broadcast by something that no longer exists. Or, more strangely, the white hole might be the first sign we see of something that won't end for trillions of years. Time in these scenarios is no longer a river. It is a braid, interwoven strands that touch, separate, and reconnect in ways we can't fully trace. One event leads to another, but not always forward. Not always behind. It's difficult to live inside a mind shaped by straight lines and still entertain a universe built from loops. But perhaps that's the challenge the white hole presents. Not just as a physical object, but as an idea that resists linear thinking. Because once we accept that a black hole can die backwards, we begin to realize that causality, as we know it, might be local, not cosmic. This doesn't mean chaos. It doesn't mean nothing matters. It means the rules might be deeper than we thought. That what seems like randomness might, in fact, be order on a different scale. And that some of the most violent things in the universe, the collapse of stars, the birth of singularities, might not be endpoints but bridges. Hidden tunnels carved by the logic of the universe itself. So what happens to the matter? The stars, the gas, the information once swallowed by a black hole? Does it all come out again? The mathematics says, maybe, but differently. Not whole, not intact, but transformed. Not the same particles in the same shape, but the echoes of their presence. Patterns reconfigured, entropy revised. And if those patterns emerge into a different part of the universe, or a different epoch entirely, what would they look like? A sudden burst of radiation? A fog of subatomic particles drifting outward? A new structure forming in the void, cold and bright and unbound by any past? We don't know. We only know that the equations keep pointing us toward possibility, toward symmetry, toward something that, if it exists, has been hiding not because it's small, but because it operates on scales we were never meant to hold. But we try anyway. We build instruments. We map the sky. We wait for something strange to flicker at the edge of perception. Something that doesn't belong. A white hole, not as theory but as truth. And if that moment ever comes, if we do see it, If we confirm the transition from black to white, then we will have to rethink what time is, what direction means, what the universe is actually doing when it turns stars into silence, and silence into birth. Because if dying can become ejecting, if collapse leads to eruption, then the cosmos is not a story of things ending. It is a story of things returning. It's a strange comfort, in a way, to think that nothing is ever truly lost. That even in the deepest dark, something waits to return. Not because it remembers, but because the laws of nature demand it. The symmetry we see in physics, the balance between action and reaction, between particle and antiparticle, between creation and collapse, doesn't stop at the edge of a black hole. Persists, quietly, impossibly, invisibly, until perhaps it reverses. And this reversal doesn't look like a rewind. It isn't a film running backward or a moment undone. It's more like inversion. A shift so complete it seems like a new thing, but hidden inside is the echo of what came before. The collapse that was once inward now turned outward. The gravity that once held everything in, now pushing everything away. That's the paradox at the heart of a white hole. It is built from memory but offers no past. It throws matter outward but reveals no center. It exists but cannot be entered, probed, or undone. To an outside observer, it looks like an origin, a source, but to the math, it is a continuation. The other side of a singularity, playing out not next to the black hole, but as its consequence. And in that vision, time is not just flexible, it is two-faced. One face looks back, toward the past, tracing every motion to a cause. The other face looks forward, or perhaps outward, toward emergence. Toward the things that simply appear. White holes don't require permission. They just arrive. No warning. No symmetry we can see. But maybe a symmetry the universe keeps hidden in the way it bends itself, like a ribbon folded so tightly it touches on both sides. Some theorists go even further. They suggest that in the deep future, when the last black hole evaporates, when the last bit of Hawking radiation flickers into space, there will be a final act. A white hole. Not a burst, not a bang, but a bloom. The release of everything that was ever trapped. A last exhale. And maybe that exhale doesn't end in emptiness, but in structure. A new phase. A new geometry. A new universe. Because if one black hole leads to one white hole, then what about all of them? Every galaxy harbors a supermassive black hole at its center. Billions of them silently feeding, growing heavier, darker, denser. If every one of them is destined to become a white hole, then we live in a cosmos seeded with futures. Each black hole a chamber of waiting. Each white hole a pulse, delayed. And perhaps the universe we see, expanding, cooling, dimming, is only half the picture. The other half hasn't arrived yet. It is still in the process of reversing. And perhaps that's why we haven't seen a white hole. Not because they're fantasy, but because we're too early, or too late, or standing in the wrong direction. This is the haunting beauty of the black to white transition. It isn't just a theory of physics. It's a theory of time, of how things connect, of how loss can be a shape, and how that shape might twist back on itself to form not a void, but a beginning. Maybe this is what happens when the universe tries to balance its own equations. It doesn't erase, transforms. Every fall becomes a rise. Every silence becomes a sound. Not immediately, not locally, but eventually, somewhere. And so, the white hole becomes not an object to find, but a question to carry. What if nothing we've ever seen has truly ended? What if everything that falls is waiting to return? What if, right now, something ancient is emerging elsewhere because of something collapsing here? The laws are silent, but the patterns, they suggest. They whisper. They keep us looking at the night sky not just for what is there, but for what might be echoing through it. A ripple, a ring, a bloom of light with no center, no cause, no explanation. And maybe when that day comes, when the white hole appears unmistakable, we won't greet it with surprise, but with a quiet recognition, because some part of us will already know we've seen it before. We've lived through its other half. We've fallen into the black, and now we're watching it rise. If a black hole swallows and a white hole expels, then some part of us wants to ask, what connects them? Is there something more than just reversal? Could there be a path? A hidden tunnel cut through the bones of the cosmos, linking collapse to eruption, gravity to flight, past to future? This idea is older than it sounds. In 1935, Albert Einstein and Nathan Rosen imagined a kind of bridge, an abstract solution to the equations of general relativity. They weren't thinking about teleportation or science fiction. They were thinking about symmetry, about the possibility that two black holes, connected by a tunnel in spacetime, might be one object. One curve, folded back on itself. The mathematics allowed it. In a world governed only by Einstein's equations, such a tunnel could exist. A shortcut between two distant regions of the universe, or two distant moments in time. A wormhole. But the math, as always, gives and takes. The Einstein-Rosen bridge was there, but only for an instant. Pinched closed the moment it opened. Unstable. Fragile. A whisper of possibility that the universe immediately silenced. Still, the image remains. A black hole as an entrance. A white hole as an exit. And between them, something no one has ever seen, but everyone has imagined. A hidden corridor where time warps and distance collapses. Where space folds so sharply that the shortest path between stars is not a line, but a bend. And if such bridges exist, they could change everything. Not just where we can go, but when. Because in general relativity, space and time are not separate. To move across great distances quickly is also to move through time. Wormholes, if real, might not just be cosmic shortcuts. They might be time machines. Of course, this brings problems. Big ones. Paradoxes. Loops. The kind of contradictions that make physicists sweat and philosophers smile. What happens if you enter a wormhole and emerge before you left? What if you change something? What if you become the cause of your own birth or your own death? These questions aren't just fanciful. They're dangerous, because they test the limits of causality, the bedrock of science. They poke at the idea that the past is fixed, the future open. They threaten to undo the simple sequence of before and after. And the universe, it seems, doesn't like that. Every serious attempt to make a stable wormhole in theory runs into trouble. Exotic matter is required, stuff with negative energy, something we've never found. Tiny fluctuations become massive. The tunnel shakes, then collapses. Even a single photon passing through might be enough to destroy it. As if reality itself resists the idea. As if these bridges are not roads we can walk, but reflections only visible from one side. Still, the equations won't let it go. They keep suggesting shapes, geometries, gently curving tunnels that hold, for a moment, the structure of connection. They don't promise stability. They don't offer safety, but they whisper of symmetry, of unity, of hidden relations between objects that seem separate. And some theorists take this further. They suggest that entanglement, the deep quantum link between particles across space, might be the same as geometry. That when two particles are entangled, they are not just connected by information. They are connected by a thread, a line of spacetime, a wormhole so small it cannot be seen, but not imaginary. Real, physical, binding. This idea has a name. R equals EPR. A bridge between the Einstein-Rosen wormhole and the Einstein-Podolsky-Rosen paradox of quantum entanglement. It suggests that the fabric of space itself might be woven not from points, but from connections. That the threads of the universe are not places, but relationships. Not things, but the way things hold together. If that's true, then black holes and white holes might not be endpoints. They might be stitching, nodes in a vast, invisible web. Places where reality folds hard enough to show us the seams. It's beautiful, but beauty isn't evidence. And so we wait. We build theories. We run simulations. We try to find even the faintest sign that these bridges exist. Not just in math, but in matter. That somewhere out there, or in here, the tunnel is real. And yet, every time we reach for it, it vanishes. But sometimes the universe doesn't answer with facts. It answers with hints, shadows, behaviors that seem familiar, yet offer no origin. Some physicists have begun to wonder if wormholes might not appear directly in our telescopes, but subtly in how gravity behaves, in lensing events that don't quite add up, in the strange delay of light that curves, not just around stars or galaxies, but possibly around something else, something hollow, something curved inside itself. They ask, what if wormholes aren't stable in the long term, but flicker open in brief moments? Microseconds, nanoseconds, gaps so short we could never catch them, but just long enough for something to pass. Not a spaceship or a person, just a photon, a pulse, a whisper of energy that travels faster than expected and disappears before we can follow. Some theories suggest that in the quantum foam, this boiling sea of spacetime fluctuations at the smallest scale, tiny wormholes are constantly opening and closing, not stable, not useful, but present, as if the universe is constantly practicing how to connect itself, making, unmaking, remaking passages that will never be crossed but are still real, still part of the architecture. This might explain the odd cohesion of the cosmos, why particles seem entangled across impossible distances, why black holes, despite their isolation, still radiate information. If space itself is threaded through with tiny bridges, then maybe separation is an illusion. Maybe nothing is really alone. And yet, the deeper we go into this idea, the more unsettling it becomes. Because if wormholes exist, even tiny, temporary ones, then causality becomes porous. Information could travel through a shortcut and emerge not just elsewhere, but elsewhen. A decision made here might ripple across time. A signal sent now might arrive before it was created. It's not that time travel becomes real in the sense of science fiction. It's that the boundaries around time itself begin to blur. The sequence of cause and effect of past and future no longer runs in only one direction. It becomes dependent, conditional, contextual, and we begin to ask, is time a line or a tapestry? And if it is a tapestry woven from wormholes and loops, then where do white holes fit? Perhaps they are not destinations but leaks, tears in the fabric where the pressure of a collapsing black hole reemerges, not in the same place, not in the same time, but through a weak seam. Not a stable tunnel, but an emergency exit. A place where energy and information are released because there is nowhere else to go. Some suggest that wormholes and white holes are different names for the same thing, seen from different sides. That a wormhole is a tunnel still holding together, while a white hole is the burst that happens when the tunnel can no longer hold. Collapse becomes connection, and connection becomes release. There's something poetic in that. The idea that what we call exotic or speculative might be ordinary at the scale of the universe. That space-time under pressure does what life does, finds a way out. But poetry isn't proof. And so we look. We stare into the darkness. We measure, calculate, simulate. We send out questions with no promise of reply. Wormholes remain hidden, if they exist at all. And white holes, if they're the end of these tunnels, remain even more elusive. They don't appear when we expect. They don't announce themselves with clarity. They arrive, if at all, like ghosts from another logic. And maybe that's all they'll ever be. The universe, if it's anything, is patient. It hides its bridges in folds too subtle to unfold. It tucks its passages behind curtains of uncertainty, buried in the noise of random motion and cosmic dust. And yet, the idea lingers, that somewhere behind the clean silence of mathematics, wormholes breathe quietly, that a black hole's collapse doesn't just end in nothingness, but sets something else in motion. Something deeper than a singularity, a transformation. We've spent decades trying to build pictures of it. Visuals, diagrams, equations etched on chalkboards in quiet rooms, trying to map the invisible. We draw circles, loops, spirals that cross themselves, arrows that bend. And each time the answer is close, so close we can feel the edge of it, but never whole. The wormhole closes, the bridge collapses, and we are left again with only the silence. But maybe that's the point. Maybe these structures are not meant to be held, only hinted at. Maybe they're not machines to be engineered, but patterns to be sensed. like the way gravity curves light, or the way a particle knows another state without touching it. Not doors we can open, but shadows we can learn to read. And white holes, if they exist, may be the punctuation to those shadows. Not ends, not beginnings, but the moments when the pressure becomes too much and the hidden geometry beneath the surface speaks. It doesn't speak in a language we know. It doesn't shout. It simply appears briefly on the edge of what can be measured. A flare without a source, a structure without a past, a moment without a cause, and then it's gone. In some theories, these flares leave marks, subtle signatures in the cosmic background, tiny anomalies in the distribution of energy across the sky. Not loud, not obvious, but there. Cold spots, concentric rings, unexpected silence in a place where noise should live. Echoes of something erupting not from a point in space, but from a fold in time. Some say this is fantasy, that the math is indulgent, that nature wouldn't waste time with such delicacies. But nature isn't in a rush. It has eternity, can afford to draw loops we don't understand, to build tunnels we'll never walk, to balance equations across epochs and dimensions we haven't named. And perhaps, from nature's perspective, wormholes and white holes are not exceptions. They are the rule. Not strange, but inevitable, because in a universe governed by symmetry and continuity, collapse must have its counterpart. Descent must lead to return, and silence eventually must answer back. So we continue the search, not for proof but for presence, for patterns that don't fit, for pulses that have no cause, for flares of matter and energy that seem to appear, impossibly, from nothing. And every time we find one, we ask, is this it? Is this the moment the bridge held? The flare released? The white hole appeared? And even when the answer is no, we keep asking. Because the question isn't just scientific. It's instinctive. It's the same question we ask of time, of death, of meaning. Is there a way through? We don't need to know where the wormhole leads, only that it leads somewhere. And if, someday, we discover that the universe is full of connections we can't yet perceive, that white holes are more than mirror ghosts, that wormholes are more than theory, then maybe we'll also discover something else. That we, too, are part of the bridge. That every act of observation, every question asked in the dark, is a thread pulling the fabric tighter, closing the loop, carrying us closer to something not beyond space, but folded within it. Not later, now. There is a moment in every story where the beginning becomes a question. Not just when or where, but how, and deeper still, why. In the story of our universe, that moment is the Big Bang, the spark that lit everything, the singularity that bloomed into space, time, matter, energy. We've traced its fingerprints in the sky, in the cosmic microwave background, in the patterns of galaxies, in the elemental ratios of hydrogen and helium. All the evidence points backward to something that wasn't a place, but an event, a beginning without a before. But what if it wasn't a beginning? What if the Big Bang was not the start of everything, but the continuation of something else? This is the question that has begun to haunt the minds of physicists. Because the more we learn about black holes, about white holes, about symmetry and collapse and reversal, the harder it becomes to ignore a strange resemblance. A white hole, by its nature, is something that erupts. It ejects everything it contains outward, in every direction. It has no past, only a violent present. Cannot be approached, only receded from. Its contents do not fall inward, but explode outward, forever, unstoppably, as if some cosmic pressure had built for so long, in silence, and then, finally, was released. That sounds familiar. Because the Big Bang, too, had no known cause. It has no observable precedent. There is no moment before it. Only a wall, an asymptote of knowledge where the equations break and time itself may not exist. And what emerged from it was everything. All the matter, all the energy, all the potential that would ever become stars, galaxies, planets, people, suddenly there. Not gradually, instantly, as if blown out from some hidden chamber we could never enter. Some have started to wonder, what if that's because the Big Bang was not a birth, but an exit? Not a creation ex nihilo from nothing, but an emergence from somewhere else. A rupture. A passage. A transformation. What if the Big Bang was, in truth, a white hole? It's not just poetry. The equations allow it. If white holes exist, and if they are the mirror of black holes, and if black holes collapse space into a point so dense that time stops, then perhaps on the other side of that point something happens. Not in the same place, not in the same time, but somewhere else entirely. A burst, a release, not of what we call this universe, but of a new one. One that doesn't remember what came before. One that begins in entropy, but contains its own rules, its own constants, its own clock. From our side, it looks like a beginning. From another side, it may have looked like an end. And if that's true, then we have to rewrite the question. Because we've always asked, where did the universe come from? But now the question bends. Now it becomes, what collapsed to make this eruption? What was lost so that we could begin? What black hole, vast, ancient, unknowable, shrunk to a point, reached its final quantum trembling, and opened? We may never know. The event horizon hides the answer. The passage between collapse and emergence is wrapped in the mathematics of uncertainty, and space itself may not carry memory across that bridge. But the possibility that we are living in the release of a death we did not witness is hard to unsee. And it doesn't stop there, because if one black hole led to one white hole, and that white hole became our universe, then perhaps that is not a rare event. Perhaps it is the only event. Perhaps every black hole, in every universe, is the seed of another. And what we call the cosmos is not a single isolated structure, but one blossom in a field without edges. Not a multiverse of branching options, but a lineage, an ancestry of fire and silence. Each universe born from the singularity of collapse in another. Each white hole flaring outward into its own space, its own time. No longer mirrors, but generations. And perhaps that is what eternity looks like. Not repetition, not stasis, but renewal. A chain of transformations, each unaware of what came before, each pulsing with the residue of collapse. In this vision, the Big Bang is no longer the ultimate mystery. It is the first clue. But this idea, this inversion of birth and death, does more than challenge our physics. It unsettles our sense of time. Because if the Big Bang was the endpoint of something else, then what we think of as before and after may be tangled, unraveled, folded into each other like the pages of a book turned inside out. Our universe, with its orderly expansion, its cooling stars, its growing voids, may not be the first verse in a long cosmic poem, but a reply. And replies come after something. So what kind of universe could give rise to ours? What shape must it have had to produce such a clean release? No leftover matter, no lumpy geometry, just a rapid, smooth expansion obeying the laws we now take as fundamental. Could it have been a collapsing universe? One that, like ours, had grown cold and sparse and then began to fall in on itself? Not into ruin, but into a final gesture. A singularity so dense it cracked the script? Some physicists call this the Big Bounce. A cycle in which universes collapse and re-emerge, each white hole birth carrying the imprint of a black hole death. But others see something stranger. Not a loop, not a rhythm, but a one-way passage. That black holes in some parent universe reach quantum limits, and instead of remaining silent forever, they flash once, and all that was within explodes out, not here but elsewhere. In that moment, a universe is born, not from nothing, but from compression. A fire not of creation, but of release. It sounds poetic, but nature, it seems, allows for poetry if the math permits it. In general relativity, nothing prevents the emergence of a white hole. It's just that we've never seen one. They appear in equations symmetrical to black holes, but they are unstable, difficult, fleeting. No known process in our universe should create them, except perhaps the death of a black hole itself. And this is where theories begin to converge. Because quantum gravity, in some formulations, doesn't just predict the end of black holes, predicts their reversal. Not because of choice, but because of necessity. When a black hole shrinks to the Planck scale, to that unknowable edge where space and time lose meaning, something must happen. And the most elegant answer is that it becomes something else. It becomes what it cannot contain anymore. A white hole. And if that is so, if white holes are the inevitable afterlife of black holes, then the question becomes sharper, darker, and far more intimate. Was our entire universe the echo of something else's end? That question strikes at something deeper than curiosity. It forces us to see time not as a straight arrow, but as something more like a spiral, or a breath, expansion as exhale, collapse as inhale, not cycles that repeat, but motions that respond. One universe collapsing there, another exploding here, and in that breath, everything we know, our stars, our atoms, our memories, are part of a pulse that began with the death of something else. Not a myth, not a metaphor, a physics we cannot yet complete, but cannot ignore either. We often picture the Big Bang as a sudden explosion into emptiness. But what if it was more like a jet, narrow, directional, shaped by the geometry of its origin? What if the energy that filled our universe came not from nothing, but from a crack sharp and narrow, like a wound torn open by pressure too great to contain? It would explain the symmetry, the balance, the order that followed. Not chaos, not randomness, but structure, seated by something collapsing in an altogether different cosmos. And that changes more than physics. It changes our story. Because if we were born of collapse, then perhaps the quiet of our cold future is not the end. Perhaps, somewhere, the particles that form us will fall into a black hole. Perhaps that black hole will shrink. And perhaps, long after we are gone, that point will flicker open. Not here, not now, but somewhere else. And something entirely new will rise, carrying a whisper of what we once were. If the Big Bang is a white hole, then it isn't just the beginning of everything we know. It's the aftershock of something we'll never know. A memory not our own, released in the form of stars and time. We live inside that memory. We are made of it. But we cannot see the event that triggered it because we are the consequence. There is no window looking backward into the thing that died so that we could begin. The only traces we have are the way space expands, the way time flows, the way matter arranged itself into silence, light, life. And still, we wonder, if this is the other side of something else, then where is that something now? Does it still exist? Or did it vanish when the singularity cracked open? Was it another universe with its own laws, its own physics, perhaps its own concept of reality, one that, by collapsing, gave rise to us? And if so, what did it lose when we were born? Was its death as silent as our birth was loud? Or was there a moment, a tremor, a realization on that side of the wall, when it knew the end had arrived? That is a question no theory can answer. Not yet, but the silence around it is compelling. In our models, the universe doesn't simply begin with a bang. It begins with perfect balance, an expansion that carries exactly the right ingredients to form structure, to allow complexity, to build observers capable of asking these questions. That doesn't feel accidental. It doesn't feel arbitrary. It feels like inheritance, as though the structure was imprinted, as though the fire of birth carried the echo of design. Not divine, not deliberate, but mathematical, gravitational, inevitable. Some theorists lean into this. They imagine a branching multiverse, where each white hole creates a new cosmos, each with slightly different laws, different strengths of forces, different outcomes. Most are sterile. Most collapse immediately or expand too fast for anything to cohere. But some, rare and golden, have just the right balance. Just enough time. Just enough structure. And from those, intelligence arises. Eyes that look back. Minds that wonder. In that sense, perhaps we are the consciousness of collapse. The brief moment in the history of this white hole universe where matter becomes aware, becomes reflective, becomes capable of asking, what was before? And the answer, if there is one, may be forever out of reach. Because the wall between collapse and expansion is not just a physical limit. It's a narrative one. Our story begins in explosion. Anything that happened before cannot be part of our timeline. We can't access it. We can't influence it. We are the result, not the cause. But even so, the question lives. Maybe that's what makes us human in the cosmic sense. Not that we build or explore, or even survive, but that we ask. That we stand in the middle of expansion and still feel the pull of something behind us. That we look at a universe hurling itself outward and wonder what fell inward to make it so. And maybe, in the deepest possible reading of white holes, that's their function, not to be found, not to be studied, but to remind us that nothing exists in isolation. That every eruption comes from pressure. That every origin has a weight it doesn't show. So perhaps the Big Bang wasn't the first act in a cosmic play. Perhaps it was the curtain falling on another stage. One we will never see. One whose actors are gone, whose time is closed, but whose final breath became our entire sky. And if that's true, then we are not the beginning. We are the echo. We've always seen black holes as endings, as the place where light fails, where time slows to silence, where meaning dissolves into darkness. But what if they're not that at all? What if they are invitations, doors not locked but turning inward? And what waits beyond them is not nothingness, but pressure, tension, waiting to become something else. Maybe white holes are that something else. Not objects, but moments. Not destinations, but eruptions. The impossible reversed. Silence breaking open. Matter refusing stillness. And in that defiance, something ancient, something weightless and wild, is returned. Perhaps that is what our universe is. Not a cradle, not a machine, but a scream, a memory pushed outward from a place where memory collapsed. And if that's true, then so are we. Not born from design, but from recoil, from the recoil of something that could no longer hold us. Life, light, consciousness, thought. Maybe they are not the opposite of death. Maybe they are its echo. Not to understand, but to continue. Not to explain, but to witness. And maybe in that witnessing the loop closes and begins again.